actually figuring out the value of a variable. So that's what we're going to be looking at, solving exponentials and logs.
Dude, I had to study on 6th grade, but that's all full 7th grade, so I only have 5 classes. I know. But my 4th period is on, so finish your work on Monday.
No Air Force, they fly around in that camper. And that brother like that.
Tuesday.
Early, that's why you got to score the highest right. Well, I mean, that doesn't mean like. It just means that they're pretty much the smartest right out there. That's the retarded ones that are stupid. That's not real men. Just makes you retarded.
Not really.
I mean, yeah, they're men, but
How are they not men?
it just, you don't have to.
Are you a man, Trevor?
In the Marines.
Are you a man?
We know you are.
I'm not.
Alright, what we have here, this says, y'all be quiet, this says 100 to the x power is equal to 1/10 to the x minus 3 powered. So now we're actually solving for x. We're not just rewriting anything, we're solving for x. So one of the very first things we started off with a while back was if the bases are the same, then the powers are the same. Okay, so I need, if I'm looking at something like this that has numbers like 100 and 1/10 that look like they might have a number in common, that's what you're going to do is rewrite them with the same base, because what you're trying to find, the exponent, is your variable. Okay, so 100 and 1/10. What do you think you could rewrite those with the same base of? What makes sense for 100 and 1/10? 10. Very good. So 100 is the same as 10 squared, and then there was already an x up there. Okay? Now, what do I do to 1/10? Because all I need to do is flip it. What kind of exponent makes a 1/10 flip? When we have a certain kind of exponent, we put something in the opposite spot. What kind of exponent is that?
Negative.
Negative. Very good. So this will be the same as 10. And I don't want to change the value of it. I want it to stay 10. So 10 to the negative 1. And then there's still an x minus 3 up there. Okay, so now if 10 equals 10, and it does, right, then it means our exponents have to be equal to each other too. So we're going to say 2x is equal to, I'm going to go ahead and distribute this -1, negative x plus 3. Now it's just like a normal equation that you learned how to solve in middle school. What would we do to start solving that? Okay, good idea. So we got 3x equals 3. Then what?
X equals 1.
Divide by 3 and x is 1. So if we had another one like that, again, what we need there, if I had 81 to the x power, that's equal to 1/9 to the x plus 3 power. Okay, so we're trying to solve for an exponent.
9 squared.
Okay, 81 and 1/9 should bring a 9 to your head. 81's the same as 9 squared. Now, could you do any other number on that? I think 3 would probably work, wouldn't it? But 81 would just be less work. Excuse me, I mean 9 would be less work since the right side already has a 9, right? So 9 would be the good one that Trevor had for us there. This will be 9 squared. And don't forget there was already an x there. Now, what do I do to a 1/9 if I just need to flip it?
Just negative.
Negative, very good. -1, and there's already an x plus 3 there. Okay, you finish that. You've got the bases set equal to each other, so that means the exponents have to be equal to each other. Finish it like we did the last one. Well, this is a fairly easy one. We're going to have to do log ones, but it's still pretty easy. Should have started off by distributing your -1. That would have got you 2x equals negative x minus 3. Then what did you do from there? Okay, good. We'll add that x, bless you. So 3x is -3. Austin's got it. Yes, sir. All right. So far on both of the ones that we had, we rewrote them to have the same base. So what base do 2 and 7 here have in common?
14. Is that right? No.
What times itself would make 14?
7 times 2.
And that's not 7 times itself, because when you do powers, it's times itself.
Oh.
So that makes this one a little bit tougher, doesn't it? Because 2's not a perfect square. 7's not a perfect square. So the only thing that would be, but how would you even write 2 with a 1? 1 to the what equals 2? Yeah, well, that's okay, because there's not a same base we can use here. Okay, so that's when this problem's a little bit different, but it really is easier. Okay, so when we can't find the same base, we're going to rewrite into the other form. So which of those two forms do we have?
Top.
The top one that spells bin, that's exponential form. So we're going to rewrite that into log form. So what would this look like in log form? Log base what? 2 of 7 equals. So we're trying to find x. All you got to do is enter this in your calculator. Math. Go down to log base. Fill in the blanks. Now does it make sense to you that you're going to get a crazy decimal answer?
Yeah, because there wasn't a...
Very good, Chloe. Very good. So let's round it to hundreds. Give me 2 decimal places.
2.81.
They get about 2.81. Because we did 2 cubed, that's 8. So it's got to be less than 3. If we did 2 squared, that's 4. So it's got to be bigger than 2. So that makes common sense check for you. That's right. Okay. Alright, see if you can get that one. This is just like the one we just did. Solve for x. 3 to the x equals 8. Common sense, check yourself. I know the answer's got to be almost 2.
Yeah.
Because 3 squared would make 9, but I need 8. So it's got to be pretty close to 2, but a little bit smaller than 2. Let's do 2 decimals again. What do you got, Austin? Okay. Hearing some people say they got about 1.89. If I did this, this would be log base 3 of 8 is equal to x. So log base 3 of 8 would be what you entered in your calculator. All right? All right, check this thing out. Now we've added something else up there with the x. 7 to the 9x equals 15. Okay, we're still going to start the same. Stephen's right. This would be log base 7 of 15 is equal to 9x. So you're still going to start it the same way, but when you get done, that'll be what 9x is. So then what would you do? Austin, go divide by 9. Okay, because my x is being multiplied by 9. So go ahead and tell me what log base 7 of 15 is, and leave it on your calculator. Don't clear it off. Okay, so it's about 1.39, but don't clear that off. I don't want you to round it off on your calculator. That's equal to 9x, right? Trying to solve for x being multiplied by 9. So now with that big long answer on your calculator, just hit divided by 9. Okay, so that way, the reason I wanted you to keep it on your calculator so you didn't have to round multiple times, the less you round, the more accurate your answer is. Does that make sense? Alright, one more of these and then we'll move on. This one says 4e, got to get our number e, to the negative 0.3x power, and then minus 7 is equal to 13. So it looks like there's a lot going on in this, but it's not very difficult. Just looking at it, good. Just looking at it, your gut should tell you what to do first based on middle school. Steven's already got it. What do y'all think?
Add 7.
Add 7. That's a good idea. So this is what I call getting rid of extra junk. Wonder about now. Think there's any other extra junk you could get rid of?
Divide by 4.
Very good. That e's being multiplied by 4, so we can divide both sides by 4. So we have e to the negative 0.3x is equal to 5. Any more extra junk to get rid of? No. So now let's go ahead and write it as a log equation. Okay, so this would be log base e of 5 is equal to negative 0.3x. What's log base e the same as? Nope. Log base e.
Log base 1.
No. Good idea though. It's called a natural log. What's the symbol for natural log?
LN.
ln. Log base e is the same as ln. We made a note on that one day. So ln 5 equals negative 0.3x. So now to start simplifying this, you're going to hit ln 5. ln is on the far left next to the 4. Leave it on your calculator, but tell me a few digits. 1.61. What will you do to finish solving that?
Divide by negative 0.3x.
Yes, ma'am.
Or negative 0.3.
Uh-huh. So what do you got?
Negative 4.
I got negative 5.37.
They need help getting that? So I like this better than the stuff we did the last couple of days because now we're finally getting to figure something out instead of just rewriting stuff. Alright, so far everything has started off as an exponential equation. Now I'm going to start them off as log equations. See what we got to do to those. Okay. This one says ln of 4x minus 7 is equal to the ln of x plus 5. Now this one's about the easiest kind there is. Any guesses on this? Good. Good. If you've got ln and ln on both sides equal to each other, then that means that that also has to equal that, right? So, just as a normal little algebra step here. What we got? What do you want to do? There's 4 places you could start. Where would you like to start? Okay, Stephen was at 7 first. You didn't have to start there, but it's alright if you want to. Now after your first step, you don't have a choice about what to do next. Okay, that's probably what I would have done first, but we still get the same answer. 3x is 12. So what was x?
4.
X is 4. Okey-dokey. Here I got log base 2 of 5x minus 17 is equal to 3. On the last problem, we got to just drop the logs off. Can't do that here because I don't have one on both sides. So, when we had some earlier that were in exponential form, we rewrote them in log form. Now I got one in log form. Guess what we're going to do? Write it in exponential form. So my base is 2. What's my exponent? 3. Good job. Equals what? Good job, that whole piece. Y'all are pretty good at writing 17, not 12 either. Y'all pretty good at writing those. Alright, you know what 2 cubed is? 2 times 2 is 2. That's just a 2-step equation to solve now. 25 is 5x, so what's x? Whoop, whoop. Not to it.
We're going to the test over this?
Next week. Alright, this next problem that I'm going to throw at you combines yesterday's stuff. I got log of 2x plus log of x minus 5 is equal to 2. Alright, so the first problem that we did when we switched to log equations had a log on both sides, ln and ln. This one, they're not on both sides. The second one we did just have one log. This one's got 2. So this is a completely different type of problem than the other 2 that we did. If I can get this condensed, there was a hint, down to 1 log, I can work it like the last problem. So does this involve one of the properties from yesterday that would let me write it with 1 log? Which one? Okay. Addition is friends with product. Remember from yesterday? So this is the same as multiplying those. So the log of 2x times x minus 5 equals 2. Okay. What's the base here? Nope. No. No. No.
0.
No. There's no base written. It's an understood. No.
E.
No. 10. No base written, and we made that note the same day we made the E note. Y'all might need to, y'all didn't know either one of those. Y'all might need to rewrite those. Log base E is ln. Log base 10 is just log. Okay, so this one there's no base written, so it's an understood base of 10. What's the exponent that goes with my 10? Good. Exponent's right there, so Stephen's got that too. And then it'll be equal to all of that. Can I go ahead and distribute that 2x when I write this? Be alright? 2x squared minus 10x. Go too far? Is that alright? Okay, 10 squared. We got a hundo there, right? Now, we got a quadratic. When we solved quadratics all in the first semester, what did we always have to set them equal to? 0. So I need to move that 100 over. So this is going to be the same as 2x squared minus 10x minus 100 is equal to 0. If we subtract the 100, where'd the 100 come from? 10 times 10, 10 squared. Okay. I'm going to do what Stephen said. I could use quadratic formula like it is. They're all divisible by 2. If I take a 2 out, that's going to make it a lot easier to do that factoring that Trevor just talked about. So if I just reduce this by 2, that would make x squared minus 5x minus 50. What factors of negative 50 add to negative 5? x minus 10 times x plus 5. Which means set both those equal to 0. What do you get for your x's?
X equals 20.
Very good. Opposite signs. Alright, this lesson spends some time with inequalities, which is a greater than or less than sign. You do those the same way. I'm going to do one just so we can make sure we get it covered, but you do them the same way, so it's not anything different. Okay, got it? So if you saw something that said 3 to the x is less than 20. Okay, this is one of the easier problems. What form is that in? Logarithmic or exponential? Does it say log or does it have an exponent? It's got an exponent. It's exponential. Very good. Can I make 3 and 20 be the same base like we did? No. So that means I'm going to write it in log form. So I would have log base 3 of 20 is less than x. So see, we're doing it the exact same way. Just instead of an equal sign, you got a less than sign. Okay, log base on your calculator. Figure out what log base 3 of 20 is.
2.72.
2.72 is less than x, so that's a good way to write it. I always like to put my x first, so I might flip everything and say x has to be greater than 2.72. Either one of those would work. So you do it the same way. Okay, don't panic and act like it's a new problem if they put a greater than or less than sign in there. Alright, wanted to do this so make sure you know when to do what. That says 3 to the x plus 1 equals 81 to the x minus 2. That's exponential form. It's not log form because there's no logs. But I'm not going to rewrite this one in log form. What is different about it that I know I'm not going to rewrite in log form?
Can you set your exponents equal?
I am going to get my exponents equal to each other in a second. So Trevor's on the right road. But why am I doing that this time instead of writing it in log form? It has to do kind of with what Trevor said.
They both have exponents.
Good, they both have exponents. So what would go in the E spot, right? You've got 2 of them. So before I can set the exponents equal to each other, which is what Trevor said what we're going to do, my bases also have to equal each other. So this is like the first problem we started with. What can 3 and 81 both be?
9.
No.
Where's that?
What about 3? Very good, Chloe. 3 and 81 is the same as 3 to the, times 3 is 9, times 3 is 27, times 3 is 81. See, if I did 9, to make it to use this here, I would have to have done the square root of 9. That would have just been ugly and wouldn't have worked real well. Okay, so now we got our bases the same, so we're ready for setting those exponents, like Trevor said. X plus 1 equals 4x minus 8.
Plus 3.
Okay, what?
We can solve it? Or,
Yeah, what do you want to do?
Plus 8.
Okay, Trevor's adding 8. X plus 9 is 4x. What do you
What
got?
about 4?
Not yet.
No.
Minus 8.
Yeah.
Good. So 9 is 3x. Now we're ready, Chloe, to divide. So x is, yep.
Okay. Oh, we only have 15 minutes left.
Oh, my goodness. Oh, my goodness.
Only 15 minutes. Can't do another one.
I don't think we got time for it. Alright, solving for x. Wants you to round to the nearest hundredth. There'll be a spot for you to put your answer in the classroom.
Yeah, the long base 5. Long base 5. 12.
What then? You're gonna be like, oh, she's kidding. I don't want to know. But he looks like a boy who's really nice, and I think that's why yeah, not my medicine.
Alright, the spot is in my classroom, so I might need to refresh yours.